So in this video, we're going to be looking specifically at the rational zero theorem. You'll see kind of a summary of it on the board that says all possible rational zeros, and rational just means anything that can be written as a fraction. All possible rational solutions, zeros, have this same form. Plus or minus, that'll be already put into Hawks. You don't have to type that sign in. Plus or minus the factors of the constant over the factors of the leading coefficient. So let's look at two examples. So the first example says f of x equals 3x cubed plus 5x squared minus 26x plus 8. Step 1 is going to say find all possible zeros. So that's using that theorem, which says take the constant. So that would be of 8. So I'm looking for factors of 8 over factors of the leading coefficient, which would be 3. So the factors of 8 are 1 and 8, 2 and 4. And those are my only factors. The factors of 3 are 1 and 3. So to find all the possible zeros, it's going to be every combination of the top with the bottom. So what I mean is you'll have 1 with 1 and 1 with 3. So you'll have 1 over 1, 1 over 3. And then you'll do the same thing, but with the other number. So then you'll have 2 over 1, 2 over 3. And then you'll do the same thing with 4. 4 over 1, 4 over 3. And then you'll have the last one, 8 over 1, 8 over 3. Now, if any of these things simplify, of course simplify them. So now I can kind of work through, well, 1 over 1, that's the same thing as 1. 1 over 3 doesn't simplify. 2 over 1, that's the same thing as 2. 2 over 3 doesn't simplify. 4 over 1 is 4. 4 over 3 doesn't simplify. 8 over 1 is 8, and then 8 over 3. So there are all your possible zeros, and then of course the positive and negative versions. So right now I would pause the video, type this function into your calculator, and then we're going to talk about in the next part how do you find the actual zeros. So type this into your calculator. So in the second example, alright, so now that you've got it typed into your calculator, you'll see a picture of my calculator in the bottom corner. When I typed that thing into my calculator, I found several zeros. So I see already that I have a solution, and a solution. Now, 2 of those 3 are whole numbers. So let's look at what 2 those are. I have this one right here, which is x equals negative 4, and that one, x equals 2. Now that third zero is somewhere between 0 and 1, so you can handle this a couple of different ways. Now it just so happened that I only have one possible zero that's between 0 and 1. So if you look back at the list of numbers we just wrote, we said that x, a possibility, was 1 over 3. That was on the previous screen. So I'm pretty sure that's 1 over 3 because I said this had to be the list of possible zeros, and I only have one between 0 and 1. However, I'm going to show you more of an algebraic, especially in the event that you have more than one possible zero in that little area. So again, I am looking at this area right here, that point, and I don't know exactly what number it is because it doesn't fall on a whole number. So the way you would do this algebraically you're going to take one of your solutions. So I know -4 is an answer. So I'm going to take -4 and I'm going to do synthetic division on my function. So using these coefficients. So I've got 3, 5, -26, and 8. So complete your synthetic division. So I've completed my synthetic division, which is going to give me 3x squared minus 7x plus 2. Now I'm going to take that thing and I'm either going to factor, because I'm seeing it on my graph, it's probably factorable, but I'm either going to factor or do quadratic formula on it. So it looks factorable to me, so I'm going to try that. I get 3x minus 1, x minus 2. Set each piece equal to 0 and get x equals 1 over 3, and the other one gives me x equals 2. Now I already found 2, but this just confirms that yes, 1 over 3 was indeed the actual solution. So to answer the question, find the actual zeros. Your actual zeros are going to be -4, 1/3, and 2. So here's my second example, 2x cubed minus 9x squared plus 4x plus 15. So it asks for the possible zeros, which is going to tell me that I'm doing my theorem. Says the factors of the constant over the factors of the leading coefficient. So I'm going to have the factors of 15 over the factors of 2. So my factors of 15, 1 and 15, 3 and 5, and that is it. 2 just gives me 1 and 2. So I'm going to do every top with every bottom. So I have 1 over 2, which is going to give me 1 over 1 and 1 over 2. And then I have 3 over 1, 3 over 2. And then the next one's 5 over 1, 5 over 2. And then the last one's 15 over 1, 15 over 2. Go through and simplify. So I don't need to write 1 over 1. I can just write that as 1. And I can just write 3 over 1 as 3. 5 over 1 is 5, and 15 over 1 as 15. And none of my other fractions simplify, but if the fractions need to simplify, simplify them. So there are all my possible solutions. And again, it is the positive or the negative version of any of those numbers. So that's a lot of possibilities. So I'm going to use my calculator to narrow it down to the 3, at most, the 3 that I need. So take a moment, pause the video, type this thing into your calculator, and then we're going to pick up with the actual solutions. All right, so you've got the thing typed in. Your calculator should look like mine over on the right-hand side. So you type that thing in, and you see this graph. So I see a few, or 2, real zero or whole number zeros. So those are the 2 I see that would be pretty easy for me to identify. So that one on the far left is x equals -1, and the one on the far right is x equals 3. So I just am missing this one in the middle. That point right there, I don't quite know what it is. Now it's definitely between 2 and 3. So we can go back and look at our list of possible zeros and see which of those fall between 2 and 3. So I noticed that the only solution I have between the numbers 2 and 3 out of my list of possible solutions is 5 over 2 or 2.5. So I'm fairly certain that that's the missing zero, but just in the event that your list is incorrect, here's the algebraic approach to just confirm that number you actually got. So I would pick one of my zeros. I'll pick -1. do synthetic division on it using the actual function at the very top. So I have 2, -9, 4, 15. And then I'm going to fill this out, and I'll have then a quadratic. Now I have a quadratic which I can factor or use quadratic formula. I'm going to factor because it looks factorable to me. So I factor it and I get 2x minus 5 and x minus 3. Set each piece equal to 0, which will give you 2x minus 5 equals 0, which will give you x equals 5 over 2. And then the second one, x minus 3 equals 0, which will give you a solution of 3. Now, I already found 3 from my graph, but that confirmed that, yes, the 5 over 2 was indeed the actual 0. So, your solutions are -1, 5 over 2, and +3. That is your final answer.